Hey guys, welcome to Conceptual Geometry, Unit 9, Day 3. We're going to do some mixed circle problems. So the first example, we have to find W, X, Y, and Z. And what I recommend when you do these circle questions is do not necessarily do those in order. What I like to do is I like to look around the circle, see what I have, and work from there. So first thing I'd like you guys to identify is a diameter. Remember, it always divides a circle into two equal parts, so 180 degrees and 180 degrees. Since this arc here is 110 degrees, and these two are equal, those two are equal, we can take 180 degrees minus 110, that gives me 70. And divide that by 2. So that gives me 35 degrees. So Z I know is 35 degrees, and this arc over here is 35. I might need it later, maybe not. So there we go, 35 degrees. Looking up above, what do we know? I've got a central angle here. And if you guys remember, a central angle is equal to the arc. So I know X is going to be 70 degrees. So X is 70 degrees, and what's left for us? Well, we've got this angle Y, arc Y, sorry, and it's part of the top half circle. So if I want to find that, what I need to do is I need to take 180 minus 60 minus 70. All right, and that will give me 50. So it gives me Y, 50 degrees. That arc is 50, and the last thing to do is find W. That is a central angle. It's also part of this straight line. So 180 minus 70 is 110 degrees. Okay, the nice thing about these circle questions is you guys will notice there's often more than one correct way to do it. So if you saw something differently and got the same answer, chances are you did it correctly. All right, next one. Let's see, what are we given? We're given this arc here is 105. And again, a diameter. Diameters are great because I can get half circles, semicircles. So this arc here is 180 minus 105. So that's 75 degrees. So if the arc is 75 degrees, the central angle is also 75 degrees. So W, 75 degrees. Now, other than that, this is a little bit challenging. One of the things I want you guys to note is that we have this triangle here. And I'm given this angle down here, but what I want you guys to realize is that that triangle has to be isosceles because it's formed by two radii. So these two angles are equal, which means that one's 58 degrees. And then to get X, I take 180 minus 58 minus 58. So that is, I believe, 64. So this angle here is 64 degrees, which makes Z 64 degrees because it's the central angle equal to the arc. And lastly, we have Y. And to get Y, it's part of this semicircle. So you just have to take 180 minus 64. All right, I believe that is 116. Moving to the next one. I think you'll notice a common theme here. All of these are going to have a diameter, which makes them very simple. And again, I'm not going to pay attention to the variables. I'm just going to work my way around the figure. I've got a central angle right here. That's 35 degrees, which means this arc is 35 degrees. How is that useful? Well, I can now use that to get this arc W. I will take 180 minus 35. That gives me 145 degrees. So that's going to be arc W. Now working with the bottom half, what do we know down there? Well, I've got this arc is 120. So I can find this one over here, which is Y. It's the other half of that semicircle by taking 180 minus 120. That's 60. So Y is 60 degrees, that arc. I can put it in up here. Now, this might make it easier but you don't need to find it. I know this angle is 60. Some of you might prefer to use this straight line. So those two angles are supplementary. But some others of you might recognize, since this arc here is 120, that central angle's got to be 120. So Z is 120 degrees. And then there's a couple ways you can find X. Probably the simplest, I want to incorporate it here because we haven't talked about it yet in these examples, is use the fact that it's an inscribed angle. And an inscribed angle is equal to half of its arc. So X is going to be 1/2 of 60, which is 30 degrees. Again, that's not the only way you could have gotten that angle. Some of you may have found it a different way and still got 30 degrees. You did it correctly. All right, moving on to the next one. 3 more. Again, notice the habit here. This is the pattern, I should say. Get your diameter. Pretty straightforward. Once we get that diameter, I have this arc, which goes to that central angle. So the central angle here has got to be 68 degrees. There's your W. On the other side of that, this angle, Z, forms a straight line with W. So together, those two have to add to 180. So Z is going to be 180 minus 68. All right, so that is, what, 112? So Z is 112. And then X is the arc of this central angle. So the central angle is equal to the arc. So that's got to be 112 degrees. There's your X. And to find Y, again, there are a couple ways to do this, but I want to emphasize inscribed angles. So let's take a look at that inscribed angle. Y is equal to half its arc. That goes to 68 degrees. Half of 68 is 34. All right, this one looks sort of complicated, but we only have to find 2 things. We need to find A and B. Now, what's challenging about this, for the first time, we don't have a diameter. So we're kind of forced to use inscribed angles. The first one I want you guys to look at, because it's the easiest, is the one that's 40. Now, when it comes to inscribed angles, I'm going to write down this formula. An inscribed angle is equal to half the arc. One of the things you want to remember is that the arc is greater than the inscribed angle, because you have to take half of it. So if I give you the angle is 40 degrees and the arc has to be bigger, you know to multiply by 2. So to get A, I'm going to take 40 times 2. That's 80 degrees. So this arc right here is 80 degrees. That one. Now to get B, B is also an inscribed angle. But notice the arc that B intercepts is this one. So the arc from here to here is 80 plus 25, so that's 105. So to calculate B, you have to take half of 105 degrees. Now we're going to see some decimals occasionally. When I take an odd number and divide it by 2, it gives me a decimal. So this is 52.5. Don't freak out if you get a 0.5. That just means you had an odd number, you divided it by 2. And finally, the last one. Again, we only need to find 2 variables, but it's a little bit more challenging because I do not have a diameter. So how do we go about doing this? Well, we have to recognize some inscribed angles again. So this is an inscribed angle. The angle is 28 degrees. The arc has to be bigger. So to get X, you have to take 28 times 2. All right, so that gives me 56. Okay, so now X is going to be 56 degrees. So this arc here is 56. What else do we know? We know this arc here, let me use blue, is 95. Let's see what we need for Y. Y is an inscribed angle. It's going to be equal to half the arc. So I need this arc here, which I don't know. Now if I knew 3 of the arcs, so if I somehow could get this one as well, all I could do is subtract those from 360 to get the red one. Now, what I want you to notice with that yellow is that it goes to this inscribed angle, 35 degrees. So that is actually going to be 35 times 2, or 70 degrees. Okay, so now I know that's 70, I know that's 95, and I know that's 56. So to get the red arc, I have to subtract those from 360. 360 minus 70, minus 56, minus 95. That is 139. So the arc is 139 degrees. So y is the inscribed angle, will be 1/2 of 139, which is 69.5. All right, great. So that concludes day 3. I know I went a little bit quickly here, so please don't hesitate to pause the video, recheck your answers. If you came up with a different method but you got the same angle measure, most likely it is correct. All right. Thanks for watching, guys, and we'll see you in class soon.